Hello everybody and welcome back to this tutorial, and right now let us code our ARP spoofer, which will spoof the router and the actual target, which will be on our Windows 10 PC, in a while true loop. So right now, let me just see, go to my Python programs, go to scanning, or pardon me, not scanning, go to local area or local network programs. Here we have our Mac change from the previous videos, and we want to nano ARP spoofer, spoofer.py. So press enter right here, enter our usual user bin Python line, and we want to import the actual scapy library, and we can do that with the import scapy.all as scapy. So this is the way that we actually want to import it, so we can use an easier syntax, and for now on that is all we want to import. So what we are going to do in a main function, so let me just add it right here, main function, we call it right there, and then we will code it right here, and all we want to do is actually try and accept to spoof, and accept to spoof the target. So we will run an actual function which we will call spoof underscore ARP, and there we will specify the IP addresses, and we need to run it twice since we are actually running spoof underscore ARP, since we are actually running the two different spoofs, which one will be for our router and one will be for our Windows 10 PC. And also what we want to do is actually try this in a while true loop. What this will actually mean, let me just show you, is that we are going to run this as long as we don't interrupt with our keyboard. So we'll just code it like this. Let me just add a little bit space so this looks a little bit prettier. And let's see what we want to actually paste to our spoof ARP. We can't really paste the MAC addresses since we don't know the MAC addresses of our targets, but we do know is the IP addresses. So we know that the IP address of my Windows 10 PC is .1.5, and the IP address of my actual router is .1.1. So let us specify the two arguments for both of these functions to be the IP addresses of the router and also the IP addresses of the Windows 10. So we can do that with the 192.168.1.1, comma 192.168.1.5. We now do the same right here, but we will do this in a different order. So first we will specify the IP address of the Windows 10, and then we will specify the IP address of the router, since we are spoofing different targets with this. So since we made our spoof function, what we want to do is actually code that function right here. So let us code it with the spoof ARP. We need to set def right here, and we need to paste the arguments, which will be, the first argument will be the target IP that we actually want to target. So in the first case that will be the router, and the second argument which will be the IP address that we actually want to fake. So the target IP underscore IP and the spoofed IP underscore IP will be our two arguments right here. The spoofed IP basically means that the IP address that we are going to pretend to be while sending the packets to the target IP address. So in order to actually be able to do all of that, what we need to do is actually get the MAC address of our target. So in order to get the MAC address of our target, we will select the MAC to be equal get target MAC from the target IP. Now this function doesn't exist, of course, so we have to code it. We named it def get target IP, so we will name it the same right here, or not IP, MAC, and as an input it will take the IP address. Since we specified right here that we want to select an input of the actual IP of our target, and all we need to do right now is actually specify the same process that we did in the previous video, which will get us the MAC address of the actual target. So we can select the ARP request, for example, since we are sending the request to be equal to the scapy.arp. We need to select the p destination, which is the destination of our target, to be equal to the IP of that target. And we also need to select a broadcast packet, which will actually be the ether packet, which will contain the MAC address of the broadcast, or basically which will contain the broadcast MAC address. So we will do the same as in the previous video, FF, 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 and once again FF, close the quotes, and all we have to do is concat these actual packets to a final packet, equals broadcast / ARP underscore request. So let us recap. What we are doing is we are creating a request that will actually contain in the p destination field the IP address of our target. Now all of the other fields we don't have to actually select, since they are, as we saw in the previous video, automatically selected by the ARP, by this KP itself. We created a broadcast packet that will actually has a field of the broadcast MAC address. This means that it will send to any machine on the local area network, and we used both of those packets to make it a one big packet, which we called final packet. So all we have to do is actually type right here that the answer, so we will do the same as before, equals kp.srp, which stands for basically sending and receiving the answer. We want to send the final packet. Let's select the timeout for this packet to be equal to 2 seconds, just in case. And all we want to do is select the verbose to be false, since we don't really need to actually look at it, and that it doesn't really provide any useful information to us. And we want to select the first list, which will be the list of our answers. We don't care about the second list, that's why we only use the first part of the list that we receive from the actual response. Now all we want to do is actually select right here that the MAC equals the answer. We select the first part, then the second part, and we want to select the hardware source, which, if you remember in the previous video, I made a mistake. I, for example, specified the hardware destination, and I was confused why we actually got our Kali Linux MAC address. But right now, since this is a different packet, this is a response that we are getting, we need to specify the hardware source, since this is the source of the target that is sending us back the response. You just see, so software update not now. And all we want to do right now is return from this function with our MAC variable, which has the actual MAC address of our target. So then we will specify the MAC address right here, as we have it right there, and all we want to do is actually send the packet. So we will call that packet, which will be spoof packet. We want to select it to be an ARP packet, so you can do that with kp.arp. Now you might notice that in the previous video we only used the ARP, we didn't have this kp. Prefix. Now, since we are using this as a Python program and we imported it as a library, as kp, we need to use the kp prefix in every function that we use from the kp library. So let's code this packet. We want it to be a response, which we can select with the OP field equals to the hardware destination, with the actual MAC address of our target that we are spoofing, which we got from the getTargetMAC function. So we will just paste it to be equal to MAC, since our variable returned the MAC address from that target. The p destination is the actual destination of our target, so we can just select the target underscore IP. And the p source will be the source or the IP address of the machine that we want to actually fake, which is the actual spoofed IP. So in this case, we are sending the ARP request, the ARP replies to the router, pretending that we are Windows 10. So all we have to do right now is, since we created our packet, all we have to do is actually send this packet to the router. So we can use the functions kp.send. We send the packet and we set the verbose to be equal to false. False. So close the actual brackets, and basically this is it. This is our entire ARP spoofer. As we can see right here, we are both spoofing the ARP tables of the router and the ARP tables of our Windows 10 PC. So let us see how this will actually work. So let me just save this. Before I do any of that, let me check the MAC address of the router in ARP-A with the ARP-A command, so ARP-A. We can see that it is all good for now. 192.168.1.1 is set to be at this MAC address, which is 04-CEO, and so on and so on. So with this program, we should be able to change that for as long as we want. So we have our ARP spoofer. Let's make it an actual executable. And let's run it with Python 3. We let this run. Expected and intended block. So let us see what is wrong with our code. We nano it. Okay, so we didn't code anything in the keyboard interrupt part. So we can just try right here to code the actual exit the program. So let us try right now. No module named scapy.all. So let us see why doesn't it have scapy.all. Let's actually go to the Python 3 in order to see how we need to import the scapy. So import scapy. From scapy.all import scapy. We see if Python 2 has it, so import scapy. So Python 2 actually has it, so let's actually try to run it with the Python 2. We are running our ARP spoofer with Python 2 right now. And if I just go right here and run the ARP-A once again, okay, so we are still, okay, so right now as you can see, we saw the live moment where it actually changed to the MAC address of our Kali Linux machine. So our ARP spoofer is working. We are successfully actually spoofing the target. As we can see that the MAC address of my Kali Linux machine and the MAC address of the router are both the same on our Windows 10 ARP tables. We can see if we run it once again, it will remain to be the spoofed MAC address as long as we are running this program. And since we are not actually forwarding the packets between each other, you can see if I go on my internet, so let me just click on the Google Chrome. And if I actually try to open a page, any page, it will not connect to the internet. So we can actually try to go to the facebook.com. We press enter in order to try to actually load the page. You can see it is not loading it. It will not load the page fully. As you can see right here, I lost my connection. I get the error that there is no internet. So this actual program, in case you're not forwarding the packets, can actually make a DOS attack on the entire local network. So nobody on the local network, if you were to example spoof multiple targets, will be able to actually connect back to the internet. So let's see in the next video how we can actually make the packets go from our Kali Linux machine to the router and Windows 10 PC, so we don't actually kick everyone off the internet, but we will see that in the next video, as well as actually fixing our program with a few different things. So hope you enjoyed this video, and I hope I see you in the next one. Bye!